Algebra 1 students, welcome to your 8.2 lesson video. We're going to talk about how you multiply and factor. We're going to work with different polynomials. In this section, we'll focus primarily on multiplying a monomial and a binomial, but we could expand our thinking as we move along. So the big idea, or one of the two big ideas today, is when we multiply, you want to use the distributive property to multiply your monomial by a polynomial, any number of terms. All right, so let's practice that. The first one says to simplify and write in standard form. So I see 4x times the quantity of 3x minus 7. This is simply a matter of doing 4x times 3x and 4x times negative 7. And we'll go ahead and simplify that. And I would imagine most of you will get to the point where this first step I've written, you actually will just skip right past it and go to what we have right here, positive 12x squared plus 28x. All right, why don't you pause the video and do number 2. We have one extra little thing we run into there, but go ahead and pause and hit play when you've finished problem 2. Okay, you can see my work on number 2. The little extra thing we have to deal with here is when you initially multiply, we're not in standard form. The instructions clearly say to write in standard form. That means descending powers. I had a 2, then a 3. I needed to reverse that. The negative is attached to that 10x cubed term, so it goes with it. All right, let's take a look at number 3. We're going to follow the same process, but notice this time we have a trinomial inside the parentheses. So we're going to actually have to multiply 3a by 3 different terms. 3a times 4a is 12. A times a squared would be a cubed. 3a times 5a, well, 3 times 5 we know is 15. A times a is a squared. And then finally 3a times negative 1 is negative 3a. All right, we have one more like this to look at. We have an extra step involved here as well, a little different one. It's basically a double distribution situation. So I'm going to take p and I'm going to distribute here and here, but I also need to take that negative 3p and distribute to both places. So what I'll have is p times p, p times 2, and then negative 3p times p would give me negative 3p squared. Negative 3p times negative 5 would give me a plus 15p. Now again, writing in standard form is important. Also simplifying is important. You notice here we have a p squared and a minus 3p squared. I want to combine those. And then I have a 2p and a 15p. Combine those as well. We get plus 17p. All right. The other big idea that we're looking at today, factoring. Factoring a polynomial is the opposite of multiplication. We wouldn't call it division. It's undoing multiplication though. To factor, we start by finding what's called the greatest common factor, the GCF. Now a GCF, the greatest common factor, can be found at a basic level with something like just numbers. So 16 and 28. What we'd have to look at is what goes evenly into 16. Well, we know 16 is 4 times 4. We know 4 is 2 times 2. Same thing here, 4 is 2 times 2. So 16 can be broken down as 2 times 2 times 2 times 2. We could do something similar with 28, and maybe you choose 2 and 14 to start with, and then 14 can be broken down to 2 and 7. Now here's what I notice. I have a 2 there, and a 2 there, I have a 2 there, and I have a 2 there. The greatest common factor would be the product of anything that matches here. So our greatest common factor, the GCF, is 4. Now that process I showed you to find it, for some may be a little confusing. You might just want to look at what number goes evenly into 16 and into 28. And we would know the largest number that goes into both evenly is 4. Same way with simplified fractions. Okay, let's take a look at number 6. What goes evenly into 12 and into 16? Well, that would be the number 4. And I also have to answer what goes evenly into x squared and into x. That would be the highest degree that's a part of both, and that would be x to the first. Okay, one more like this. This time we have 3 terms: 14y cubed, 42y squared, and 28y. First thing I'm noticing is that 14 goes evenly into all 3. 14 times 2 is 28. 14 times 3 is 42. So 14, as far as the coefficients goes, is the greatest common factor. And in the other term, we have a y cubed, a y squared, and a y. I just simply take the highest degree that's a part of all terms. So it's y to the first. Now the reason we do that process of finding a GCF, the big picture here, is so that we can factor. So we're going to do the same thing by taking out a GCF, 8x minus 12. So if I look at the coefficients, 8 and 12, the largest number that would come out of both evenly is 4. And then what I'm going to do is divide each term by 4. 8x divided by 4 is 2x. Negative 12 divided by 4 is negative 3. The concept when I do this factoring is to say I'm breaking down this term in a little bit different way, but it's the exact same thing. If I distributed 4 times 2x and 4 times negative 3, I'd go right back to where I started with 8x minus 12. Let's try it again on number 9. The largest number for 9 and for 15 would be 3. And the largest degree exponent would be x to the second. Now, we can think of it as division, or we can think of it this way. 3x squared times what equals 9x cubed? Well, that would need to be a 3, and I need one more x. 3x squared times what would equal 15x squared? That's just simply a 5. All right, let's take a look at the next one. 10x to the fourth plus 15x cubed minus 5x squared minus 60x. First thing I notice, I'm looking at coefficients. 10, 15, 5, 60. All of them divisible by 5. The other thing we have to consider is the variable. We have x to the fourth, third, second, and first. We want to take out as many as we can, but you can't take out more than 1 because this term here only has 1, so that limits us, but 5x. All right, let's go ahead and figure out what would go in our parentheses here. 5x times what would equal 10x to the fourth is the question we're asking. Well, 5 times 2 is 10, and x times x to the third is x to the fourth. 5x times what would be 15x cubed? And in that case, it's a 3 and an x to the second. 5x times what would give me negative 5x squared? That's minus, well, 5 times 1 is 5. X times x is x squared. And then the last one, 5x times what equals negative 60x, and it's negative 12. Okay, we have one more here. Notice this one does not have any coefficients. That can be good or bad. It's fine by me. But what I'm going to look at is the a terms, a cubed, a squared. What is the highest degree a we can pull out of both? That would be a squared. Same idea with the b terms. Here we have b to the first, here we have b to the second. The highest degree that I could factor out of both would be b to the first. And then we have to look at, okay, well, how does this, what do I have inside parentheses here so that it multiplies back to where we started? A squared b times a would give me an a to the third b. And then we need to say, okay, well, a squared b times what is a squared b squared. Well, I've already got the a squared. I've got b to the first. I need it to be b to the second, so I need a b right there. All right, folks, that's your intro to factoring, just dealing with GCFs. Make sure you take careful notes and come ready to work hard to class. Have a great day.